What's up, guys? Welcome to your lesson about ratio tables. We're going to be talking a lot about what we've already done with ratios, and that is comparing two numbers. And we're also going to We're also going to talk about how that compares to unit rates. So let's get right into it. Basically, what we're going to do is take ratios and we're just going to put them in a nice, neat, boxy looking table like this. That's basically what we're doing, and then kind of manipulating it from there. So our first little example here says that to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. So you got some icing, you put a little food coloring in it, turns it yellow. How much yellow food coloring would you mix with 5 cups of white icing to get the same shade? So what we would do is literally draw out a table here, just like this, to determine how many drops of yellow food coloring we would need. Well, we know we need 6 drops for 1 cup. So we would literally put the drops we would need right here, 6, and the cups of icing we need, which is 1, right? 6 drops for every 1. That's a ratio, right? And it's actually a unit rate, right? 6 drops per cup of icing. Now the question would be, how many drops would you need for 5 cups of icing? Well, just like with regular ratios and fractions, we would figure out what we would need to do to the cups of icing to get from 1 to 5. In this case, we would multiply by 5, right, to get there. And in order to keep the ratio equivalent, we have to do the same thing to the drops of food coloring. So the drops of food coloring will also get multiplied by 5. And when we do multiply that by 5, we get 30. And 6 drops for 1 cup and 30 drops for 5 cups are equivalent ratios. But when we put it in a table like this, it makes it a little bit easier. So we could eventually even say, try and figure out how many drops of yellow food coloring we would need for 10 cups of icing, which we could do the same exact thing. And we could do times 5, or this would be times 2, right? Because 5 times 2 gives you 10. So we would just go 5 times 2 gives you 10. And if we did the same thing here, 30 times 2 would give you 60. And clearly, they're equivalent ratios, right? 6 over 1, 30 over 5, 60 over 10, all equivalent ratios. But we could use a table like this to help us figure out the answer to those types of questions, right? So you could even tell me how many drops of yellow food coloring you would need for 20 or 21 or 22 cups of icing. Let's take a look at another example. More paper in the pile. A patient receives 1 liter of IV fluids every 8 hours. That's kind of like me when I got COVID. They were shooting me up with fluids at the hospital. Yeah, this is true stuff. It's basically they put water in your veins. You ever see people in the movies with the thing in their arm or whatever with the tube? They put water in your veins to help you stay hydrated. Okay, so anyway, a patient receives 1 liter of IV fluids every 8 hours. Okay, at that rate, find how many hours it will take to receive 4 liters of IV fluids. So what we have here is we've created our table, and we have IV fluids, right? 1 liter of IV fluid every 8 hours, right? So when 8 hours go by, we get 1 liter of IV fluid. Well, the question will be how many hours would go by if we were given 4 liters of IV fluids? Well, what we know here in this ratio is that 1 goes to 4. So our job is to figure out how do you get from 1 to 4. Well, we can only use multiplication or division because those are the only operations that keep equivalent ratios. So how do we get from 1 to 4? It's probably not division that's going to get us there. I think it's multiplication. And 1 times 4 would get us to 4. And in order to keep the ratio equivalent, do the same thing to the bottom. Multiply that by 4. And 8 times 4 is 32. So we could say that for 4 liters of IV fluids, it would take 32 hours. Right? If you were given 1 liter every 8 hours. And you continue this process on. You could make this table longer and figure out whatever number you wanted to. So that's the basics of a ratio table, right? Basically trying to figure out, are we multiplying or dividing to get where we're going? And we're trying to figure out this number here, right? Now, this is where it gets interesting. This is where it gets kind of fun. Sometimes they can ask you to convert down, and sometimes you can do that in several different steps. And this is where we get to be a little creative. To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberry, right? 12 cups of sugar, 16 cups of cranberries makes the cranberry jam. Find the amount of sugar needed for 4 cups of cranberries. Say you wanted to make a smaller amount. So what you do is you have to find a way to get from 16 to 4. And you can actually go ahead and just divide 16 by 4 to get down to 4 and do the same thing at the top. But sometimes it requires a middle step. Maybe you don't know that 16 divides down to 4. Maybe you know that 16 can divide by 2, right? So if you take 16 divided by 2, you get 8, which is okay. The step in the middle is just fine. Remember, we're trying to figure out this piece of information right here, but we'll get there. We're going to do the same thing to the top. We're going to divide it by 2 as well. 12 divided by 2 is 6. So for 8 cups of cranberries, you would need 6 cups of sugar, which is true. But we're not necessarily trying to figure that out. We're trying to figure out how many cups of sugar you would need for 4 cups of cranberries. So we would have to repeat this process. We have to get from 8 to 4 somehow. Well, how would we get from 8 to 4? Well, we're going down, so it's going to be division. And we're going to have to divide it by 2 again. We do the same thing at the top to keep the ratio equivalent. And 6 divided by 2 is 3. And we find out that we would need 3 cups of sugar for 4 cups of cranberries. Each one of these ratios, 3 over 4, 6 over 8, 12 over 16, are all equivalent. But this is the answer we're looking for. How many cups of sugar would we need for 4 cups of cranberries? 3. Okay. Now, like I said, it's going to get a little creative here. And this is where it gets kind of fun, I think, because it's almost like solving a puzzle. Multiplying or dividing 2 related quantities by the same number is called scaling. Right? So we can do whatever we want with these numbers in a ratio table as long as we do it to both of them. And sometimes it can help us to get to an answer that seems like we can't get to. Okay, here's the problem. Cans of corn are on sale at 10 for $4. You can buy 10 cans of corn for $4. Find the cost of 15 cans. Well, normally what we would do is we would set up our ratio table like this. Cans of corn and the cost. We would put this. 10 cans of corn for $4. Well, how much would it be for 15 cans of corn? Right? So then what we would do is we try to figure out a way to get from 10 to 15. But you can only do multiplication and division. We can find out very quickly that you cannot do anything to 10 with multiplication or division, whole numbers anyway, to get to 15. There's nothing that will do it. So how do we figure this out? Well, here's how. Just like on the last problem where we had that space in the middle, we can actually take this ratio right here and take it up or down further than what we need to in order to help us out. So check this out. We can't get 10 to 15, but can we take 10 and turn it into something that can go to 15? Absolutely, and this is where we get a little creative. We're gonna take 10 in this case, and there's infinite number of ways you can do this, but this is probably the easiest. You can take 10 and divide it by 2. Now, why on earth would I divide 10 by 2 if I'm trying to get it up to 15? Here's why. Because 10 divided by 2 is 5. And 5 actually helps me because 5 can then be multiplied by 3 to get up to 15. So if I take it through this process of multiplication and division, kind of working the numbers a little bit, I can get it there. Now, to do the same thing to the bottom to find out what the answer is. Divide the bottom by 2. 4 divided by 2 is 2. And then multiply it by 3, just like I did up top. 2 times 3 is 6. So the question is, how much would it cost for 15 cans of corn? It would cost $6. And this is kind of fun because you be a little bit creative here and try to figure out the puzzle of how to get from 10 to 15 with multiplication and division. Try this one on your own real quick. Pause the video, see if you guys can figure out the answer to this question, right? Estimate her height in inches. If a child's height measures 105 centimeters, you need to get from 25 to 105 somehow. Okay, if you tried it out and you got an answer, let's see if you got it correct. 25 will not multiply up to 105. The closest we can get is 25 times 4, which gives us 100, which doesn't get us there. So we're going to have to turn 25 into something that will multiply up to 105. I think dividing 25 by 5 and getting it to 5 might help us because 5 will multiply up to 105. We have to do the same thing to the bottom here. 10 divided by 5 is 2. So the ratio of 5 centimeters to 2 inches will help us now because 5 will go up to 105. 5 times something will give us 105. Well, 5 times 20, let me count it. 5, 10, 15. Yeah, I can count all the way up. I think I believe 20 will get you to 100, so 21 would be 105. So literally multiply this by 21. 5 times 21 is 105, so we have to do the same thing at the bottom to keep the ratio equivalent. So 2 times 21 is 42. So the answer to the question, how many inches tall would a child be if they were 105 centimeters? They would be 42 inches. That's a conversion between inches and centimeters. So you've got an assignment today. It's got some questions that Miss Edwards made, and I'm really excited about it because they're good questions. So go ahead, try it out. If you guys got questions, make sure you ask me. I'm anticipating several. So let's get to work.